Okay, this lesson is going to be on isosceles triangle. And the first thing we're going to do is review the triangle parts relationship theorem. So basically it says if one side of a triangle is longer than another side, then the angle opposite is larger. So if this is my longest side, right here, BC, then the angle opposite is going to be my longest, or my largest angle. And if AB is my shortest side, then the angle opposite is my shortest angle. So and then angle B would be between those two values because it will go in order. So when we order the angles of a triangle, so if we look at this using that relationship that we know, what are the smallest and largest angles of LMN? Well, the largest side is LM, so the largest angle will be opposite, and that should be angle N. And that's the smallest. Sorry, I read that wrong. So the largest would be angle N, and the smallest side is 24 inches, so the smallest angle would be angle M because it's opposite. The side opposite the shortest side is the smallest angle, the opposite the longest side is the largest angle. So when we're looking at isosceles triangles, that helps us because we know that this is what an isosceles triangle is. An isosceles triangle has at least two sides congruent. So these little hash marks right here are identifying AB and AC as congruent. And we are going to label angle, this is called the vertex angle. And then the two angles that are connected, so the vertex angle connects the two congruent sides. Then the other two angles are called base angles. And we're going to find out that base angles, because these two sides are congruent, the base angles are going to be congruent. And we're going to do that by a proof. And one of the things is a proof by contradiction. And you're going to find these this section, we've got a lot of different proofs and a lot of different kinds of proofs. So in this one, a proof by contradiction is where you assume that it's not true, and then you're going to show facts until you come to a contradiction, meaning you can't have both of them. So because the original statement is true, because the opposite cannot be true. So I'll just walk you through one of these. So if we're looking at triangle ABC is an isosceles triangle, and these are our two congruent sides, and we want to prove that B is congruent to C. So if we know this using the definition of congruent line segments, we know that the measure of AC is equal to AB. Not just that they're congruent, but they're the same length. So let's assume that B and C, so this is the contradiction part. We're going to assume they're not congruent. We want to prove that they are, so we're going to assume the opposite, that they're not. So if that were true, then the angle of one must be greater than the other. So if B is greater than C, then we would know that AC is greater than AB, the opposite sides, because of that triangle parts theorem. What was it called? The triangle parts relationship theorem. Sorry. Triangle parts relationship theorem. Because the triangle parts relationship is one side's bigger than the angle's bigger. So, but this contradicts given information that AB is congruent to AC. It's saying that can't be true because these are the same. So therefore, angle B is congruent to angle C, which is what we were trying to prove. So that's kind of what a contradiction is. You assume that they're not, and you say, well, if B is bigger than C, then AC, because it's opposite, AC would have to be bigger than AB. But we know that they are congruent, so that is false. And so that proves that these must be congruent. So that's a contradiction proof. So here's the isosceles triangle theorem and its converse. So the isosceles triangle says if two sides of a triangle are congruent, then the angles opposite those sides, so the opposite angles, are also congruent. So E is congruent to F, or in other words, the base angles are congruent. And the converse says that if the two angles are congruent, then the opposite sides are congruent. So in an isosceles triangle, it can go either way. If you know the angles are congruent, then you know the sides are congruent. That's the converse, but if you know the sides, then you know the angles. So if you know either one of those, then you can show that it's an isosceles triangle. So let's prove this converse of the isosceles triangle theorem. Again, we're going to do a contradiction proof. It's written in paragraph form. We're given that in triangle ABC, angle B is congruent to angle C. So we've got those marked down here. Now we're going to assume that segment AB is not congruent to AC. We're going to say those are not congruent to segment AC. That's going to be our first thing because that's what we want to prove, so we assume the opposite. So then if AB is greater than AC, then we would know the side opposite, or angle C, is greater than the angle B. And that is by the converse of that triangle parts theorem. So the triangle parts theorem says if the side is longer than if the angle is longer, the bigger the side's longer. So this is the converse of the triangle parts relationships. And then if AB is less than AC, then C is less than B by the same thing, the converse of the triangle. So whether it's greater than or less than, then the side is greater than or less than by this theorem. But by the definition of congruent, we know that the measure of angle B is equal to the measure of angle C. Because angle B is equal to angle C, so the measures are equal. So therefore we have a contradiction. So therefore AB, because this says AB is greater than AC, but that's a contradiction. So AB equals AC, and therefore they must be congruent. Okay, here's another theorem you want in your notes and you want to understand. So it's the vertex of an angle of an isosceles triangle theorem. So the vertex angle is the one that the two congruent sides form. That's the vertex angle. It's opposite the base. And if we bisect that, bisect means you cut it in half. So then these two angles are congruent. If we do that, then we are going to form a perpendicular line, perpendicular to the base. And then these two segments are congruent. They are also bisector. That's what perpendicular bisector means. Perpendicular means for 90-degree angles, and bisector means it's exactly in half. It cuts it exactly in half. So if we take a look at a special case, is an equilateral triangle is an isosceles triangle because it has at least two sides congruent, but it's special because all three sides are congruent. So an equilateral triangle is a special case, and so there are two corollaries. Basically, they say if the corollary says if it's equilateral, meaning if these three sides are congruent, then these three angles are congruent. And the converse is the same. If it's the angles are congruent, then the sides are congruent. So that's just with the equilateral, that shows the equilateral triangles are also equiangular. All right, so let's apply some of these theorems. Let's get to some problems. So if we have an isosceles triangle, XYZ, and we've got two angles marked that are congruent. So those mean that are the base angles. If those are congruent, then we know these sides opposite, the sides opposite the base angles are congruent. So to solve for n, we know that those sides are equal to each other. So we say 9n plus 12 is equal to 15n minus 6. And now we're going to solve for n. I'm going to subtract n from both sides and add 6 to both sides. So that's 0. 18, 15 minus 9n is 6n, and that's 0. Divide by 6, so n equals 3. Once I know n, we can find the measure of leg xy by substituting in 3. So 9 times 3 plus 12 is equal to 27 plus 12, so that is equal to 39 feet. Now we want to find the measure of xz. Well, we know that those are congruent, so we could substitute in 3 here, but we already know that these are congruent, so we can say that is 39 feet as well. And we could check. 15 times 3 is 45. 45 minus 6 is indeed 39. So I want to take a look at this one. Now we're going to apply this problem. ZX is bisected, so we know that we have these congruent angles. We know W is congruent to Y. So if YXZ, so YXZ, we know that forms a 90-degree angle, and it measures 6m minus 12. Why do we know that's 90 degrees? Because this is a perpendicular bisector, remember. So if we want to find m, all we do is set 6m minus 12 equal to 90 degrees, add 12. So we have 6m is equal to 102, and 102 divided by 6, m equals 17. So there would be our value of m. Make sure you read what the question is asking for. In this case, we've got an isosceles triangle and we have the vertex angle, and we want to find the value of x. Well, what do we know about this angle and this angle? They're both x, right? And what do we know about all three angles of a triangle? Well, we know that all angles of a triangle add up to equal 180. So if I have 40 plus x, that has to add up to equal 180 degrees. So if we just simplify that, it's 40 plus 2x equals 180. We subtract 40 from both sides. 2x equals 140, divide by 2, so x equals 70. That is the value of x. All right, now this is written out. We have an isosceles triangle. It says the vertex angle is 42 degrees. So I'm going to draw a triangle, and I know that's 42 degrees. And a base angle has a measure of 2x plus 3. So one of these base angles is 2x plus 3. First, we're going to find the value of x and the measure of each base angle. Well, we're going to kind of do the same thing we did before. I'm going to set it up, and then I want you to pause and see if you can figure this out. Remember, we know that all three angles equal 180 degrees. They add up to equal 180 degrees, I should say. So that's 42 plus 2x plus 3, and we've got two of those, times it by 2, and that's got to equal 180. Or you could write 42 plus 2x plus 3 plus 2x plus 3 equals 180. Either way, you're going to get the same answer. So I want you to pause the video, solve for x, and then solve for the base angle measure. Okay, check your work. I simplified this to 42 plus 4x plus 6 equals 180 and solved to get x equals 33. Once I know that x equals 33, I can substitute it into my base angle right here. So right here. And then 2 times 33 plus 3 would be 69 degrees for the base angle. All right, let's try this one, identifying an angle measure. What is the measure of NLM? So this is the one we're looking for right there. NLM. Well, I know that this is 6x plus 1. I know this is 4x minus 11. What can we do? So if we know this is 6x plus 1, we also know that this is also 6x plus 1 because this is a bisector. And then if I look at this triangle right here, I know that that has to add up to equal 180. So I'm going to say 6x plus 1 plus 4x minus 11 is equal to, or plus 90, about forgot that, we have a 90-degree angle there, is equal to 180. And if I add these together, I get 10x, and I get 1 minus 11 is negative 10, plus 90 is plus 80, equals 180. I subtract 80 from both sides, so I get 10x equals 100, so x equals 10. Well, how does that help me? Well, a couple things I can do. I can substitute it back in. What do we know about angle M and angle L, or angle LNM? Notice this is an isosceles triangle right here, so I know that these two are equal. So this is also 4x minus 11. So if I just substitute in 4 times 10 minus 11, I get 40 minus 11, which is 29 degrees. So the measure of NLM is 29 degrees. And then we could double check and solve, and we say, well, 6 times 10 is 60 plus 1, that would be 61 degrees. And this is 90 degrees. Does 29 plus 61 plus 90 equal 180? And it does. So you can check that out. All right, triangle WXY is isosceles. So I always like to draw these out because all the letters we get confused. WXY is isosceles, and YWX and YXW are the base angles. So this should be Y, and that should be X. So YWX and YXW are my base angles. YZ, so then I've got Z here. Let's rewrite this as a Y better. And we have XYZ. This angle right here is 15x degrees. And we have YXZ is 2x plus 5 degrees. And we want to know the measure of YWX. This whole thing right here is what we're trying to find. Okay, so we want to find this whole measure is YWX. So I'm going to pause the video and see if you can figure this one out. So if I add these up to equal 180, I get x equals 5. When I substitute this in 15x, these two angles are both 15x, so if I get two of those, I'm going to get 150 for WYX.